By 2050, nearly 10 billion people will inhabit our planet, all needing to eat, while climate change challenges our food systems. Our current food system faces immense pressure from shrinking farmland, water shortages, and significant greenhouse gas emissions. Agriculture alone uses 70% of the world's freshwater, and livestock contributes to massive deforestation. We're now entering the fourth agricultural revolution, powered by data, biology, and smart engineering. At its core are three game changers: controlled environment agriculture like vertical farms, cellular agriculture for meat without animals, and precision farming with AI. Vertical farming involves cultivating crops in vertically stacked layers within controlled indoor environments, often in urban buildings or shipping containers. In hydroponics, plants grow in nutrient-rich water. Aeroponics mists roots in air, and aquaponics combines fish farming with plant cultivation. AI controls everything from light recipes to humidity and CO2 levels, optimizing conditions for maximum growth. These farms use up to 98% less water than traditional ones, require no pesticides, and yield significantly more, with 1 indoor acre equaling 40 to 50 outdoor acres. Located in cities, they cut transport emissions and deliver ultra-fresh produce, making them weatherproof and boosting food security. However, high energy consumption for lighting and climate control is a hurdle, necessitating renewable energy sources. Now, let's talk about cellular agriculture, growing real meat from animal cells in a lab, eliminating the need for traditional animal farming. This process starts with a tiny biopsy from an animal, from which stem cells are extracted and placed into a bioreactor. These cells multiply in a nutrient-rich environment, differentiating into muscle, fat, and tissue, with scaffolds used for complex cuts like steak. Cellular agriculture offers massive environmental wins: 95% less land, 90% less water, and significantly fewer emissions than traditional beef production. It also provides ethical advantages by eliminating animal slaughter and reducing risks of antibiotics or bacteria. Singapore approved sales in 2020, and the US followed in 2023, bringing cultivated meat to market. Challenges include reducing production costs and scaling bioreactors, alongside addressing consumer acceptance. Next, precision agriculture uses AI, drones, and robots to supercharge traditional farming, focusing on pinpoint accuracy. Drones and satellites capture multispectral images to spot stressed crops, while IoT sensors track soil conditions like moisture and nutrients. AI then crunches this data to predict yields, outbreaks, and optimal harvest times, guiding precise application of resources. Computer vision allows robots to identify and zap weeds with minimal herbicide, cutting chemical use by 70%. Autonomous tractors vary fertilizer rates, and robotic pickers harvest crops gently, addressing labor shortages. This leads to less waste, cleaner rivers, lower emissions, higher yields, and reduced costs for farmers. Barriers include high upfront tech costs for small farmers and spotty rural internet access, highlighting a digital divide. These three technologies aren't rivals. They form a dream team, integrating to create a resilient and efficient food system. AI can optimize vertical farm operations and improve cellular meat production, with renewable energy crucial for true sustainability across all. Precision handles staples, vertical does urban greens, and cellular tackles protein, forming a hybrid system. This shift will create new jobs in bioengineering and robotics, transforming farmers into tech-savvy managers. We must address risks like inequality and corporate control, ensuring fair access and open technology. Energy trade-offs are key. Vertical and cellular save land and water, but use power, so context dictates the best approach. These technologies can decouple food from environmental destruction, feeding 10 billion sustainably. By investing in R&D, crafting smart regulations, and bridging divides, we can shift from exploitation to innovation. The future is bright if we act now to embrace these solutions for a sustainable food system.